Happy New Year.
Section 1.1, defining functions. Let's see how this goes today. I'm also going to try to put everything on the whiteboard, okay? I'll do my best. Don't be afraid to speak up, all right? So maybe you'll say something funny like the bacon was. Okay, could you guys hear the bacon?
Yeah, I sounded like somebody was washing dishes.
All right, I want to start things off with a quote, okay? And before I get into the quote even, I'm going to tell you that when we have class, if I take the time to write something down, you most definitely need to. Okay, let me say that again. If I take the time to write something down, you most definitely need to write it down as well. Does that make sense? Okay. Let's go to, I don't want docs. That's not what I wanted. Let's try here. There it is. Google Keep. That's what I wanted. Come on, baby. Let's do the twist. Come on. It's still thinking. Quit thinking. Everything's slower on my computer for two reasons. One, because I'm projecting it up there so you can see it. And two, because I'm recording it. So, why are you recording, Coach Herman? Because I can. Actually, I want to get good at it so that literally, like, there's how many people missing today? There's 3 missing out of this class? At least 2. We got 3 empty desks, so I'm thinking 3. So that if you're not here,
Do like a live stream in the middle of class.
well, not quite a live stream, but I can then just post it onto Google Classroom. So Aiden, who's not here, could just go in Google Classroom and watch it. There we go. That's what I wanted. All right. So if I write something down, you should. So let's start things off with a quote. Okay. This is a quote by Alton Hill. Okay. And the quote is this: a short pencil is better than a long memory. Alton Hill. A short pencil is better than a long memory. First, let me tell you a little bit about Alton Hill. Alton Hill is a guy I worked with at Clemson basketball camp. He's much older than me. I know I'm old, but he would be ancient because he played basketball in high school in the 70s, late 70s, early 80s. Okay, he was from Virginia Beach, Virginia. And when he played in high school, he played on his high school team that won 3 state championships in a row. And they went undefeated for over 3 years. They went over 3 years before they lost a game. They almost won a 4th consecutive state championship. Pretty impressive. Yes? Well, I met Alton Hill and worked with him at Clemson basketball camp. And this is the statement he gave to me. A short pencil is better than a long memory. Why did I remember that? I have no idea. Actually, I do know. I'm going to share that with you. Tell me what you think this statement means.
If your pencil's short and you're using it a lot, which means your writing comes down, so you're not remembering them.
Wow. She just got deep. She also told us why the pencil was short. What else did she say? You can't answer. What else did she say?
She was right.
Writing it down. That's what this means. Writing it down is important. even if you have just a short pencil, you could write things down, right? And if you write it down, will you necessarily still remember it? Well, not necessarily, but you can look at it and then it's there, right? What do you think you could keep longer? A memory or something written down? Something written down. Okay, it's that important to write stuff down. A short pencil is better than a long memory. My hammer and my thought home here, if I take the time to write something down, you're better. If I say something that makes sense to you, write it down. If I say something or you see something that you like, write it down so that you can remember it better. I always have a hard time remembering things. You know, we talked about the other day how your brain just automatically, erases or deletes things from your brain because it's just overload. My brain is super efficient at that. Super efficient. What do I mean? I forget stuff all the time, unless I write it down. So a short pencil is better than a long memory. Not just in class, but in life. That's the one that hopefully will help you. Okay, write things down. All right. Let's start talking about section 1.1. Don't go away. I still want you. You stay right there. But I want to go back over here. Section 1.1, defining functions. What is a function? Well, a function, there's my highlighter. There it is. A function is a rule or relationship between two quantities, often referred to as input and output, such that for every input, there's exactly one output. A function is a rule or relationship between two quantities, often referred to as the input or output, such that every input, there's exactly one output. Let's go back to our notes here. Let me start with input. Input. What is input? Well, input are all the x values. Input is all the x values when we're talking about math. Another name for input could be the domain. The domain. Now, domain doesn't exactly mean input, but it's synonymous with the word input. What's synonymous mean? The same. Virtually the same. It's not identical because domain actually means all the numbers that we can put in. And I'll get to that more later. Okay? Where input means whatever it is you're putting in. Almost exactly the same, right? Just a slight difference. But so for right now, domain, input, and x all mean the same thing. Can you handle that? Okay. And then we have output. What is output? Well, that's all the y values. It is also known as range. Okay? Output is the y values or the range. Domain, range. Everybody, put your hands together in front. Domain and range. Domain and range. X and Y. X and Y. Input, output. Input, output. Domain, range. X, Y. Input, output. Let's make it a song. I have tried to use
Let's make it our morning exercise.
deep and wide. You know, there's a fountain flowing deep and wide, deep and wide, beep. You know that song? I've tried, but I can't come up with the next line. Domain and range, domain and range. There's a fountain flowing, domain and range. No. How many have sung that song in junior church or Sunday school? Oh, none of us go to church. Oh, my bad. All right. So domain and range. Okay, domain and range. The input and the output. We're going to start using input and output as much or more than X and Y. Okay, I just want to make sure you understand what input and output are as I start to talk about function. What is a function then? Function is a relationship where each input has only one output. What does that mean? Well, let's talk about it. Let's say I have a machine here. Nice, lovely, awesome machine. Okay? And I take one of those nice little wooden pencils over there, and I put that pencil into the machine on this side. Okay? And the pencil goes in, and the machine does something funky to the pencil. And out the other side comes a nice, beautiful, shiny gold brick.
What?
You like that, don't you?
Sure.
I would put
And then
that in the whole and light it from the world.
I take another pencil and I put it in to the machine. The machine does its thing. And out the other side comes a nice, shiny gold brick. That's a function. Why? Yeah. Yes.
The pencil only has one.
What's going to happen when I put another pencil in there? Gold brick. Pencil, gold brick. Pencil, gold brick. What am I doing with this machine? Getting as many pencils as I can. Boom, boom, boom. I'm going to be rich.
Staples, like a box load of pencils.
Now, this machine's pretty cool. Wonder what would happen if I put a pen in it. So I put a pen in that machine. Out come the other side. A giant flaming pile of poo.
Could be clay. Flaming clay.
I put another pen in. What comes out? Flaming pile of poo. If that comes out, this machine is most definitely a function. Why? Because if I put something in, I know what's coming out the other side. So if I put a pencil back in the machine, what's coming out? If I put a pen in, what's coming out? Poo. Okay? It's a machine. It's a function. Each input has one output. Right here, I have another machine. Looks just like that one. Looks exactly the same. I put a pencil in. Out the other side, gold brick. I'm liking it. I got another man. I'm making twice the gold bricks. Put a pencil in. No. A pen.
That's what.
Anybody confused? You know why you're confused? Because this machine's not a function. It's not working the way it's supposed to. If I put something in, I should know what's coming out. Now, I might not actually know because it's the first time I put it in there. I may not actually know until I put it in. But when I put it in, when I put a pencil in, I should know what's coming out. I mean, once I've done it the first time, I should know what's coming out, right? And if you don't, not a function. That's what's meant by each input has exactly one output. So you may not know ahead of time what's going to come out. But once you put something in once, it's going to come out the same way every time. Does that make sense? All right, let's talk a little biology. I want to give you another example of what a function is. If we're talking about biology, what is the X chromosome? Is that male or female? Absolutely. X is female. How about the Y chromosome then? Male. Okay. I'm going to keep this one short and sweet, but I need a volunteer. I need a female volunteer. Amanda, thank you. Would you please stand up?
I love being.
Okay. We see Amanda at the mall. Okay? And we see Amanda at the mall, and she's walking around holding hands with Moss.
That would never happen.
She's, okay, it's just an example. No, it's not a big deal. Okay? We see her walking around the mall holding hands with Moss. 20 minutes later, we see Amanda again. However, no Moss. Instead, she's holding hands with Zach.
Oh man.
That's not fun.
Is that allowed?
No.
Mathematically speaking, that is not allowed. No two-time. Each X may have only one Y. Each female may only have one male. And that's what it's saying mathematically, if we're talking biology. Each female can only have one male. Understand? Thank you. Would you be seated? I need a male volunteer.
Josh.
Hi, Zach.
I nominate Josh.
I nominate Josh.
Sorry, Josh. I'll get to you later.
Yes.
So we see Zach walking around the mall. Okay? And the first time we see Zach, he's walking around holding hands with Olivia. Okay? Olivia. Okay? 20 minutes later, we see Zach walking around the mall, and he's holding hands with Gia.
Who's that?
Is that acceptable mathematically speaking?
No.
How many people say no? You're all wrong.
I'm a genius.
Oh, wait a minute. Mathematically speaking, it says each X may have only one Y. Each female may only have one male. Does it say each male may only have one female? Does not say that. Now we're talking mathematical here. We're not talking real life, because Zach, if you do that in real life, bad things will happen. Do not do that. Either way, because once a cheater,
Always a cheater.
always a cheater. So, I'm not talking about real life. I'm talking mathematically speaking. Each X may have only one Y, but it doesn't say anything about the Y's. Let me give you a mathematical example of that, okay? Let me give you a mathematical example. Let's say I have this lovely chart. Does anybody tell me what this chart is called? Very good. It's a T-chart. Okay, and I've got these X values or these inputs here. This looks normal, yes?
Yeah.
Okay, and let's say I have this output.
No.
Is this a function? How many people say yes? How many people say no? Okay. Tell me your name again. Zoe. Zoe, can you tell me what a function is? Each input has only one output. Okay. Which is the input, Nelson? The X's are the input. So each one of these can have one output. That's what a function is, yes? 0. That's the input. What's the output?
5.
How many outputs does 0 have?
1.
1. What's the output? 5.
1.
1. How many outputs does it have?
1.
1. What is it?
5.
5. 2 is the input, right? How many outputs does it have? What is it? 3. How many? 3 is the input. How many outputs does it have?
1.
Which is 5. Does it matter that the output is the same for all of them? No, that's like Zach holding hands with 4 different girls.
Wow.
Playa, playa. Mathematically speaking, okay. real life, he probably wouldn't make it out of there alive.
Trump's got 12.
Do you understand? It's, you only have to look at the input. And in all honesty, there's no way, like if there were other parts of this function, I can't see them. So I can't make assumptions about them. I have to only go on what I see. Since there's no inputs that repeat, there's no way this cannot be a function. You know what I'm saying? So let's say now I put down this another input here. Let's say I put the input 2. What number do I have to put as an output for this to still be a function or to remain a function? Yes, ma'am? 5. If I put a 5 there, it's still a function, right? Because 2 would have the same output. So it would just be like we saw Amanda walking around 3 different times, and every time she's holding hands with the same person. That's okay. That would be acceptable. Yes? How would I make this not a function? I can put a 4. I can put a 7.
Put 14.
I can put a 14. I can put 100. I can put yo mama.
That would be a 7.
As long as I have to put anything there except a 5. If I have anything there except a 5, this is no longer a function, right? Why? Because that one input would have more than one output. And that's what you're looking for to determine something as a function. So, what is a function? Don't read it. I want you to tell me. We've talked about it now multiple times. I've given you a lot of different examples. Somebody tell me in your own words, what is a function? I'll wait. Yes, sir?
Every input has to have one output.
I like it. Every input has, I'm going to leave a little space here. Okay, I'm going to leave this little space. And I'm going to put one output. Yes?
Exactly.
Does it have to be exactly? Does, doesn't it? It has to be exactly or it has to be only. I probably need to put something defining in there, right?
Yep.
So let's put it. What do you want to put? Exactly or only?
I would put only.
I don't care either.
Only is only 4 words.
Only. You got it. Only. Every input has only one output. Somebody said it in the last class, they said, one input, one output. I mean, you can't get any simpler than that, right?
Is it the
One
last
input,
class?
one output. It has to have one. Chicken, chicken. Chicken, nuggets.
Nugget biscuit.
So we know what a function is. Next, I want to talk about function notation. Okay, I want to talk about function notation. If you remember, let me not go there. Let's go here. You have seen this equation. Oops. Oops. Sorry. Red. And a little bit bigger. Y equals 2x plus 3. You guys have seen that equation numerous times. Yes? Matter of fact, all right, so now, instead of writing y equals 2x plus 3, we're going to write f of x equals 2x plus 3. what I want you to realize is f of x is y. F of x is y. When it looks like this, it's called function notation. Okay? All we did was substitute f of x for y, because f of x is y, same thing. That's going to be kind of confusing for you early, but I hope it doesn't take you too long. And I want to give you a couple examples. Back in the day, when you were, I don't know, 6th grade, 4th grade, 3rd grade, you had or would be given, let's go with purple, something like this. X plus 3. Remember that? And then somebody would say, hey, what happens if x equals 5? What would you do with that 5? Yes, ma'am. We'd put it in there for the x. So we would say, hey, 5 plus 3 is 8. You remember doing that? And then you went on in your math career and somebody started saying, well, y equals x plus 3. And then they would give you this little t-chart and they would say x and a y. And your teacher would say, let's put in numbers like 1, 2, 3, 4. Oops, I'm sorry. 1, 2, 3. 0, 1, 2, 3. And then you would plug those numbers in for x, just like you did earlier, right? And you'd say y equals 0 plus 3, which is 3. And you'd put it over here in the t-chart. And then you'd say y equals what? 1 plus 3. And you'd know 1 plus 3 is, and you'd write down your little t-chart. And then you'd say y equals, which is 5. You guys done this before. Y equals 3 plus 3, which is 6. Well, now everything's going to be different. It's going to be so different. Because now we're not going to go y equals 2x plus 3. Or y equals x plus 3. Or any other thing like that. What we're going to do now, what color you want? Blue. Blue had it. So now I'm going to give you a function like this one. And I'm going to say, hey, f of x equals 2x plus 3. And now when you do a t-chart, instead of putting x and y, you're going to put x and f of x. Why would you do such a thing? Because f of x is y. All right, time out. Doesn't that look a lot different? Does this look different? How many people think that looks different? I did. All right, guys, I got some bad news for you. This is kind of like what the girls are going to do to you. Okay? She's mad about this already.
I just don't
Yeah, be talking about the girls. I ain't want to be talking about the girls. Here's what's going to happen. You're going to ask a girl out on a date. And you're going to go to pick her up. And when she opens the door, she will have already been in front of the mirror for like 4 hours. She will have put on really nice clothes, done her hair up, put this stuff on her face, called makeup, make herself look like a totally different person. Heck, she's even going to have her phone out there and selfies, send it to her friends. Does this look okay? Am I doing good? Am I ready to go? Stuff like that. And then when you get there, it's just going to be, wow. Not the person you expected to open the door, right? But it's the same person. F of x is y. When she wakes up in the morning and just puts on some sweats and goes to school, y comes to the date, f of x. Is it any different? You gotta love the same person. Understand? So even though this looks different now, because it's in function notation, it's not. That's the same thing. Y, f of x is y. This is just y with some makeup on. That's it. Okay? And then instead of doing like we did way up here, instead of that, we'll say, what is f? Or instead of what we did here, we'll do f of 0. See my inputs, I'm going to have 0, 1, 2, 3 again. We'll say, hey, f of 0 equals what? 2 times 0 plus 3, which is 3. Thank you. Whew, that took a while. So f of 1 is 2 times 1 plus 3. 2 times 1 plus 3 is? See, she was just ahead of y'all. She's just a little quicker. That's okay. All right, then we'd go what? What do you think comes next? F of 2. I know, I'm moving too fast. Equals 2 times 2 plus 3. All right, so what's 2 times 2? 4 plus 3 is? See how we're doing this? This is function notation. This is function notation. Big deal? What's really the only difference? F of x for y. And then whatever we're plugging it in, we just make it look like this. Okay? It's just function notation. That's really legitimately the only difference with function notation versus what you're used to. Can I get an amen? Amen. What did we do? What is this called when we plug a number in? Okay, substitution. When we plug a number in, called that substitution. Your book calls it something different. Does anybody know what your book calls it? Nobody?
Evaluation.
Evaluate a function. We're basically just going to substitute for the x. Another name, one I like to do, is plug and chug. Plug it in and solve it, right? Plug it in and solve it. My favorite one, though, is glade. Glade. You know what glade stands for? No. Glade. You remember those Glade commercials? Yeah, for the air freshener. What do you do with it?
You smell it.
Before that,
Throw it in your car and you go like air freshener. Take that.
you plug it in. Remember all those commercials? That said, oh, this is one of those places for a Glade plug-in. Plug it in, plug it in. Nice place for Marinilla plug-ins right there. Mm-hmm. No?
Wow.
Wait, is that the one where it's like the nose blinder? Or is that a different one?
No, that's Lysol.
I even have a Glade plug-in back there, so I get some new.
Lysol.
When I get some new air freshener stuff in it, I'll plug it in and it'll smell good. So you're going to hear me say,
And there's a first person.
you're going to hear me say glade sometimes. Let's see if he knows. Could you tell them what glade means? Do it. Do it.
One, tell us.
You don't have to do it. Just tell them. What does glade mean? You don't remember?
I didn't have your math class except for college algebra.
And 8th grade.
That was 8th grade.
It was in 8th grade too.
Thank you.
8th grade.
The camera's not about. I even told Mom and she thinks the Ray is still about it.
No, you're right. Brian has it. Thank you. Disappointed.
Is that the bacon?
Grapefruits,
That's the one that stole my snack.
grapefruits living
JJ
and
made the
dying
bacon.
every day.
Glade, I'll say that. It just means plug it in.
Oh, there's another person.
We're getting visitors today. Yes, sir. Absolutely.
I hate to interrupt you with this important math lesson that you're doing, but
Oh, it's
every input has an output. Duh.
What is glade?
Do you know what glade means?
I'm sorry?
Glade.
Lot A.
Glade. Glade.
Glade. Otherwise known as glade?
Yeah.
Oh, okay. Yeah, no, I don't know what that means.
Plug it in, plug it in. So to evaluate expressions or evaluate functions, we're just going to substitute whatever value it is in. We're going to plug it in and solve. Make sense? Cool? All right. Oh, look, evaluating functions. Evaluating functions. Look at that. You've already looked at that. Ha, ha, ha. Domain. You guys know what domain is? What's domain? Yes, ma'am. Inputs. What's range? Outputs. Woohoo! So we know what a function is. We know what domain and range is. We know what it means to evaluate. Yes? Woohoo! Section 1.1. Guess what I'm going to ask you to do now?
Homework.
What are we going to do specifically?
1.1.
Procrastinate.
1.1. Which questions do I want you to do?
Even.
The evens. I only want you to do the even questions. Okay? Now, what have I made available for you?
The one sheet.
One sheet. What one sheet?
That has everything you need to know.
Has everything you need to know in it. Okay? If you go to your Google Classroom, on your Google Classroom is the Algebra I timeline. How am I doing on time? It is third period. Good, I got 3 minutes. This is third period. Boom. There is Algebra I curriculum timeline. Come on, baby. Come on, baby. Let's do the twist.
So do we do just page 14 or page 15 too?
You do all of section 1.1. So that's how many problems? No, just a little easier. Get to the last problem. How many problems are there? 46. Divided by 2 is 23 because you're only doing the evens. 23. There's 46 problems on the homework at all. But you're only doing half of them, right? So you're doing the 23 of them. Okay, the even ones. So what I have here is, this is me doing all the even problems. It's on video. Here's what I want you to do. I want you to do all the problems you can do first. Okay, so if there's one you don't really get it, you can skip it and do the ones you know how to do. You'll maybe struggle with it a little bit, maybe look at your reading and struggle with it a little bit, but do the ones you can. Then what? Then pull up this video. Watch the problems. Make sure you got them right. And if there's ones you didn't remember how to do, get to one of those and watch it. And, oh, okay, that's how you do it. Then you do the other ones. Do I want you to watch the whole video? Not necessarily. I want you to use it for you. I would, if it was me, I would want to check, make sure I got them right. And then I would want to see the ones that maybe I didn't get right. Maybe the ones that I didn't get right, I might skip ahead to each problem and see that I got it right. If I got it right, I might not watch that problem. But if I got it wrong, I'm not going to watch that and see what I did wrong. Are you with me? Yeah. So when you come in tomorrow, you will have done those 23 problems, and you'll know which ones you got right and which ones you got wrong. And if there's something you're still not figuring out, you'll have questions for that. Does that make sense?
Yeah.
Good idea?
Yeah.
All right, now let me ask a real question. And this is for my information, so please be honest. See, I made you, literally made you, read and highlight section 1.1. Yes? So at this point, now that we've talked about all that stuff and I had an actual lesson, you've heard those things or had touched those things in some way, shape, or form at least 10 times. Was it better having read and highlighted and then have a lesson? I might say yes. Do you understand? why it's important to read and highlight. So today, this lesson was easy, wasn't it?
Yeah.
Because you already had an idea. Did you know everything you needed to know?
Yes. Or now.
Now you do. You had an idea of it, but maybe my lesson today made it better. And this is something that's easy. It's the first thing we're doing. There'll be things that'll be more difficult. And there'll be sometimes that you're going to struggle with your reading and highlighting because I won't be doing it all for you. And I won't be giving as many explanations as I did. You understand? But I hope that you see how much of an impact that can have on your learning. Can I get an amen?
Amen.
You have literally 1 minute left. And some of you have already packed up. I don't want that. When I say this is your homework, I want you to go ahead and start on it. Is that clear? Like, oh, well, I'm only going to get 1 or 2 or 3 or 4 problems done. Okay, but you got that many done. As opposed to just packing up and waiting for the bell. Is that cool? That's what I call using your time wisely. All right.